So, hello, welcome, Shane.
Thank you. Thank you. Hello. First,
Thanks for being here on our first Men&Mice webinar interview. Today we talk about Yeti DNS, but before we jump into Yeti DNS, can you tell us a little bit where you are coming from? Why are you work in DNS space?
yeah, so I worked on the internet for a while. I was a staff member at ARIN, which is the American registry, at RIPE NCC, which is the European registry for numbers. And after that, I got connected to ISC, who's the company that makes and maintains Bind, that I think still the most popular DNS software, if you're talking about servers. And working for ISC, I wasn't initially focused on Bind or DNS software, but I did eventually get asked to lead the Bind 10 project, which was an attempt to kind of fix most of the problems that I perceived with Bind 9. Make a radical change in the way software works and the way that the DNS service is delivered. That project ultimately failed, but after that point, I had to admit that I was a DNS person. So since that time, I've been working at DNS companies, doing DNS stuff. I worked for Dyn, which is a big DNS service delivery company, and previous to that, I'd worked at Affilius, which is a company, one of the registries that runs org info and a bunch of other ccTLDs and things like that. And I currently work for a company called BII, the Beijing Internet Institute, which is a Chinese company based out of Beijing. And about a year and a half ago, about a few months before I started there, they decided they wanted to look at the DNS community and see what they could do. BII, we've been involved with IPv6 for a long time, more than a decade now, and we've been involved with SDN also for many years. I think even before it became a super buzzword, we were involved with SDN. And so now we're also looking at DNS software, and that's kind of where the Yeti project comes in.
So, what exactly is Yeti DNS?
So, in order to understand the Yeti DNS, you have to know a little bit about how the root name server system works. So I guess most of the people watching this probably know basically how DNS works. It starts at the root, which are the very first servers that a DNS resolver goes to when it's trying to figure out how to convert a name into something else, usually an IP address. Right now, the root is a letter. The servers are identified by a letter. So A through M, and they're called A root server, B root server, and things like that. These root servers have been operated by 12 organizations since 1997, 1998, something like that. And these 12 organizations have not been changed so much since then. There has been a few cases where the management of a root server has moved around because a company was bought and things like that. But basically, it's the same organizations.
And the same people, probably.
Many of the same people, indeed. And so when we say that there's 13 letters, that doesn't mean there's 13 big, huge boxes somewhere. Because it's the internet, these are mostly delivered by something called Anycast, which means that for these 13 servers, there's literally hundreds of machines scattered all around the globe. And these are companies some of them are for-profit companies, some of them are non-profit organizations, some of them are departments and universities. There's several run by the U.S. government, U.S. military, NASA, things like that. And they all try to do a very good job, of course. No one gets paid for running these services or anything like that. But one of the things that has been a problem is that there's no real way to investigate how the system works. Like, we have the system that we have now, and it has basically been unchanged for the past 16, 17 years. Now, there's several reasons for that. That's also about the same time that ICANN became an organization running the internet, which is almost exactly the same time that John Postel died, Now, John Postel was one of the early founders of the internet, and one of his big contributions was the management of these sort of internet resources. So he worked before there were regional internet registries like ARIN and RIPE-NCC that I talked about. He was the guy who had a notebook, like a piece of paper that he carried around, and he wrote down who was responsible for which IP addresses, who was responsible for managing which TLDs, originally the GTLDs, then country codes and things like that. And it was all basically done because he cared very much about the internet and did a good job at it. And over the history of the DNS during the time that he was involved, the number and way that the root servers were organized changed. So originally, I believe there was 4 or 5. More root servers got added. They reached a point where there was no ability to add more because of the packet size limitations. At that time, you could only have 512 bytes in a packet, and it expanded from there. Someone came up with noticed that if we named all the servers from the same subdomain, from the same domain, that we could add more, and that's when the number of servers expanded to 13, and that's where we're at today. And then John Postel died, a bit younger than any of us would have hoped, but at that point, evolution stopped. And this was quite a while ago. And so the internet, of course, has evolved since then. There have been some changes in the root system. We've added IPv6. The root zone was signed a little over 5 years ago. We now have DNSSEC at the root. But fundamentally, the people who are running it and the way it's run haven't changed. And it's very difficult to know what changes would be necessary or would improve the system of delivering the root zone. So this is kind of the scenario of the world just over a year ago, when a few of my colleagues now, were at the WIDE camp in I believe it was in, I don't know where it was, but somewhere in Japan. WIDE is an organization in Japan which has a long history of researching network issues. They are government and education and corporations all working together to improve the Japanese internet. And one of my colleagues, Paul Vixie, had been invited. He was talking with Akira Kato, who is actually a Japanese professor working with WIDE, and one of my own colleagues, Davey Song, who works for BII. And they were talking about this problem of, wouldn't it be nice if we could research and investigate the root server system, look at alternate models, look at new technologies and things like that. So basically, I think over the course of a few beers, they decided, hey, let's try to design a system that looks like the root server system that we could use for researching technologies on it. And I guess we'll talk more about that later. And so they did. They designed a model of a production scale model of testing the root server system, and that is the Yeti project. So the whole idea is you want something that looks very much like the root server system today, but can be tested with new and interesting things, which, to be honest, are quite likely to break things. That's why you can't do these kind of tests on the real world system. And I guess we can talk more about exactly how the technology works too, but that's the basic idea. We want to do research into the root server system in a way that's not going to break the internet.
So you mentioned already BII and WIDE and Paul Vixie meeting there and having these ideas of running this experiment of having a test bed for the root name server system. Are these the organizations that are, or the individuals running the project, or are there other people also involved?
So the project, like all great internet projects, doesn't have any foundation or official organization. There's no signed documents between parties or anything like that. It's a very loosely organized group of interested people. So the three groups that we talked about there are BII, my own company, Beijing Internet Institute, WIDE, the WIDE project, which we discussed, and then Paul Vixie, who's Paul has many hats. He does a lot of different things in various places on the internet. In this case, he's just doing it as an interested individual and researcher. He does have a domain name registered that he does his work on this on, TISF, but basically TISF is just Paul in his capacity as part of the Yeti project. So these three groups act as the coordinators of the project. So we're the ones who set up the server which collects query data. We run the web server where people can go to find out information about it. We run the mailing list and things like that. And yeah, we have calls every week or two to make sure that everything's going well, organize face-to-face meetings and things like that. But those are the people involved with, as we said, coordinating it. These aren't the people that run the project or that are super responsible for it. There's two other kinds of roles. Well, there's several other roles in the project. Now, right now, we have what's called distribution masters. So, in the Yeti model, we actually, since we're trying to mimic the root zone, we have people who produce the root zone that the rest of the system will serve. In a similar way to how IANA and VeriSign produce the IANA root zone, or ICANN and VeriSign produce the IANA root zone, we have the Yeti distribution masters who produce the Yeti root zone. Right now, that is also the coordinators. So it's BII, Wide, and Paul Vixie. It doesn't necessarily have to be, but that's the way it is today. We also have a bunch of people who are running the Yeti root servers. Right now, we've got, I believe, 16 different organizations running name servers right now, something like that. It's on our webpage. I'd have to check to be sure, but something like 16 different organizations. And individuals can also join the project. And we've also got people running resolvers, which use the Yeti service. That's a very important part of our project, as well as people who are on the mailing list and discussing the research and things like that. Now, as I said, there's no way you sign up. You don't have to commit anything like that. So we don't have an exact number for the number of people that are using the Yeti project for research and things like that. But those are the rough numbers of the people involved.
You talked about that the Yeti root zone is being produced. Is it a one-to-one copy of the original root zone, or are there any changes there, or is it a completely different one?
So one thing we haven't really talked about too much is that root zone management is a very, very political issue. And oftentimes in American conversation, we talk about things being political. We mean that in a informal sense. So you might have office politics or politics on your sport team and things like that. In this case, we do mean that informal sense, in that there are a lot of organizations that have a lot of ideas about how the root zone should run as well. But we are also talking about actual politics, by which I mean governments, appointed officials, elected officials, and things like that. In the case of ICANN, for example, U.S. politicians will occasionally make statements about how the internet should work and things like that. So the root zone, the root server system, is one of those things that it's highly visible, and it's something that most people can understand even with just a passing knowledge of the internet. Well, I wouldn't say they have deep understanding, but they kind of get it. So there's a lot of people who are interested in the root zone and concerned about it running properly, which I think is fair. So the work that we're doing comes very close to this, and therefore is very politically sensitive. We try to be very careful about what we say and what we do. This is especially true because the organizations involved, one of the coordinators, one of the people that helped found the project, is Chinese. And as probably everyone knows, the relationship between the internet and China is complicated, and it makes a lot of people nervous when you start hearing about Chinese researchers looking at the root DNS servers. I didn't talk too much about the organizations that are involved with the project, but we've also got people from India and Russia, as well as the US and lots of European members, most of which are from countries which don't have any root servers now. So the reason I bring all this up is that we have to be very careful about what we do to the root zone. Our project is concerned with the root server system. We're not concerned about the root zone itself. Now, the distinction there is the root server system is kind of a delivery mechanism, right? So these are the pipes that get the water into your house, right? We're not concerned about how that water is produced or what goes in the water. We don't care about that because the internet is a series of tubes. So that gives us a lot of, that restricts the things that we can do because we don't want to concern ourselves with the contents of the root zone, but it also gives us a lot more freedom because we don't want to make people scared and concerned, and we want people to take our research seriously. So getting back to your question, what do we do to the root zone? We have on our mission statement for the project, on our goals, we say we have complete loyalty to IANA and the contents of the root zone. We do not modify it. That's our pledge to the world. And we had some people proposing that we do some experiments which involve slight modifications, which probably fit within the spirit of that, but are not completely following the letter of the law, say. And right now, it looks like we're not going to do any of those experiments because we want to be very, very careful. So what we do now, just to give the more technical details, we actually download the copy of the root zone periodically from the root servers. Right now, I believe we're using the froot server. It doesn't really matter where we get it from. The zone is signed with DNSSEC. You can verify it. We could download it from IANA, and then I think 4 or 5 of the root servers allow you to zone transfer from them, which is why we use the froot server. It's the reason we chose F was we just happened to notice that it was the most up-to-date. I've since done some research, and I'm not at all confident that that is correct. But in any case, we download a latest copy of the root zone that IANA is publishing, that the IANA root server system is publishing. And then we take out all the signatures from DNSSEC. And the reason we do that is because we need to modify the zone slightly, and we have to sign it ourselves. We don't have the ICANN keys, which is good. If we were able to get them, then the world would be a horrible place.
Yeah, it would be a major problem.
Yeah, then anyone could get it, right? But we take out, so we have to use our own keys for that, and we change the set of name servers that serves dot.
Mm-hmm. Because it's a technical necessity to do.
Exactly. And that's basically it. So we have a number of, if you look at the root zone, it'll say .ns, a.rootservers.net, B, C, D, and so on. We take that out and add our own. And that's it. And then we sign the zone and publish it. So the only change that we do is we change the name servers that are serving the zone, because we have to do that in order for it to use our servers and not the IANA servers.
Is the Yeti DNS project already operational in the sense that already experiments are running?
Yeah, as with all great projects, we had very aggressive timelines and great hopes for our success. We took much longer to get the project organized than we had hoped originally. We had a few problems that we didn't foresee having in terms of synchronizing data between the distribution masters, which I discussed, and things like that. Those were all resolved a few months ago. We've actually just concluded our first experiment, and we're working on a write-up of that now. And we've actually started our second experiment. So our first experiment was what we call the multi-ZSK model. So I don't know, do you want to talk about the details for that? Or
maybe a little bit. That might be interesting for our listeners.
Okay. So if you know about DNSSEC right now, usually the key for a zone is split into 2 parts, the KSK and the ZSK. And in the case of the root zone, the KSK is held by ICANN and is done with some magical hardware security module with split up with security officers that are flown in from all around the world, and there's a very elaborate process.
Yeah, which can be also seen during the key signing ceremonies, I guess.
Yeah, yeah. So we don't have that. People have asked us about the use of hardware security modules and things like that, but that's not really what we're interested in researching. So basically, we say no. Now, the other part of it is the ZSK, the zone signing key, which in the ICANN VeriSign model is held by VeriSign. And VeriSign generates a new one, I believe, every quarter, 4 times a year. And then that gets signed by the KSK, and that's what's used to actually sign the root zone. So in our model, we've got 3 different distribution masters who all download the IANA root zone, do this modification that I talked about replacing the IANA root servers with our own root servers, and then publish it to our actual root servers, the Yeti root servers. We have 3 organizations doing that, and until a few months ago, we all shared all of the secret key material.
Okay.
What we've done since then is the multi-ZSK experiment. So now each of the distribution masters generates its own ZSK separately, just like VeriSign does, and only gets the public part of that signed by the KSK. So we have a bit of splitting of responsibilities, and we needed to test that in production. So what this actually means, though, is that the resolvers, the people that are actually checking the signatures, need to know about all of the different ZSKs. So we've actually got four keys in our zone right now, one for the KSK and then each of the 3 ZSKs. And we needed to test that for a number of different cases. We wanted to test it if we're rolling the key, because when you go from an old key to a new key, which you do periodically, they both need to be in the zone for a period of time. So what we actually tested was having 7 keys at once, the KSK, as well as each of the ZSKs rolling, to verify that would work. There's a few interesting things that happen with that. One is because of all this extra data, which is cryptographic and everything, the things get bigger.
Yeah, large packages.
Large packets, that's right. And we start encountering interesting things like a fragmentation. The packets become too big to fit into our packet size. Now, we're using only IPv6, and IPv6 has a minimum packet size that every network is supposed to guarantee to be supported of 1,280 bytes, or octets if you're in the IETF, but I call them bytes because I'm old school. So what a lot of DNS software will do is just split the packets at that limit. And once we passed that size, we started getting 2 packets. We discovered a bug in someone's root server, a Yeti root server, because they were using some sort of Linux kernel filtering, which had a bug that didn't support it. And these are the kind of things that you expect to find, and that's what we found. And we ran through all the tests. We ran it for a while. We've captured all the packets to see what the behavior on the traffic was. We discovered some problems with secondarying. These are all being written up. It was actually really cool to see this actual kind of real work being done.
That means having 3 zone signing keys that not all zone signing keys were signing the whole zone. There weren't 3 signatures on all data. Instead,
Correct.
There was 1 signature, but it could be one out of 3 different signatures.
Correct. DNSSEC has, I believe it's an explicit in the standards OR. So if any of the signatures verify, then you consider the data to be correct. That's important for when you're rolling the keys, of course. So we took advantage of that. And yes, so when you do a normal query, like if you're looking up, belastingdienst.nl, that's the Dutch tax authorities, you'll do the lookup, and you'll, I forget where I was going with that. Anyway, sorry, my brain just died. Oh yeah, you do a normal lookup for belastingdienst.nl, and you'll get only the answer and the signature for that one signature. So it doesn't expand the size of most queries. It's only this kind of priming query, we call it, that you need to have additional data.
Yeah, have all the public zone signing keys, which are all the DNS key resource records, or the
Yes.
DNS key resource record set of the root zone, which is then quite big, or can be quite big in case of a rollover. Yeah.
Yes. Yeah, it can be quite big, and we actually exceeded 1,500 bytes, which is another magic limit in the networking world, because that's normally the packet size for Ethernet.
Yes. Okay.
So,
but this only happened when all the keys are rolled at the same time, so it could be with careful orchestration avoided.
Possibly. But what we wanted to do, because we're experimenting here, is we wanted to see the worst case behavior, which turned out to not be so bad. But I'll be honest, I haven't finished looking at the data traces. So what I'm hoping is that we'll get some interesting graphs. We'll see how much of an increase there is with TCP traffic, for example. We'll see if there's additional retries because of packet loss and things like that. It'll be interesting to dig into that data. I just haven't had a chance to do that yet.
The results of the experiments, will they be available publicly on the Yeti DNS website or elsewhere?
Yeah, we have a commitment to do everything in as public as possible. So we've actually designed a experiment protocol for how we do our testing. In this case, we don't mean protocol like packets on the wire. We mean protocol and like a series of steps for doing things. And what I wanted to do was make sure that Yeti was as useful scientifically as possible. So one of the things that's happened in the larger scientific world lately is people have started to look at how research is done. And for example, there was a big problem in the medical community a few years ago in that if you were doing a research on a type of drug, for example, to see if it was effective, if you were doing a single study and you say had 20 patients and 10 of them it worked for and 10 of them it didn't, if you excluded the 10 that it didn't, that would be considered research fraud, and rightly so. However, if you had 10 different papers and only half of the papers showed successful results and you excluded those, no one noticed. It was called the file drawer effect, which meant that only papers that showed the results that were interesting to you would be published. And so one of the things that's been done to combat this is that if you're going to look for something now, you say it in advance so that you can't just not publish uninteresting things. Another related thing is that if you have a whole bunch of data, you're going to find something interesting. It's the law of large numbers. There's always some pattern somewhere in there. So what I wanted to do is make sure that no one could accuse us of sort of manipulating the story by changing what we're looking for after we started. So in our experimental protocol, we state in advance what we're going to do, and we say what we're looking for, and then at the end we publish those results. So in this case, it was fairly simple. We did some lab tests first to make sure we weren't going to break our production network. Even though it's an experimental network, we don't want to do things which are just going to break stuff. And then we published what we're going to look for in the experiment. And to be honest, really all that we're looking for is that we don't break the network, that the thing continues to function. And then we're going to look for these other interesting things in terms of retries and fail it back to TCP and things like that. So that's our plan. And like I said, I've written the first draft of the report. My colleagues are reviewing that now. I haven't done going through all the data yet. It's actually already on GitHub in my own private account. Once we're happy with it, we'll do a pull request and pull it into our public GitHub, the project GitHub, say. We do most of our technical documentation and things on GitHub. It's just a convenient way to share proposed changes and things like that. We may turn this and other results into more academic papers. So that will involve, I'm hoping my colleagues will do that. They have more experience with academic journals than I do. So we need to, the results that I've written, for example, don't have a lot of background and explanation of how DNSSEC works and how the root servers works, because I assume that people on the Yeti project who are interested about it and are reading their paper are going to already know about most of this stuff. So an academic paper needs a little bit more background, so probably twice as long, and maybe have some, I don't know, LaTeX graphs and stuff like that. But yeah, it should all be public. That's the idea.
Cool. You mentioned that the Yeti project is IPv6 only. How realistic is that for testing something like the root server system? Because the internet will be dual stacked for a long time. Might that not be that maybe the project is missing some side effects that only occur in a dual stack network, but not in a pure IPv6?
So I think there's a few aspects of that. That is a valid criticism, and one possible answer to that is that, well, we've got 11 or 12% of the internet using IPv6 today. It's doubling every year, I guess, something like that. So in a few years, IPv4 will be a fond memory of network engineers sitting around talking about the good old days when we talk about our PDP-11s and things like that. But I think realistically, that's probably not the case. We're going to need to support IPv4 forever and ever. However, another possible answer to that is that if we were going to make modifications to the existing IANA root system, it might be difficult to draw a lot of conclusions from some of the results that we're going to publish. However, one possible answer to that is that there are many ways that you could alter the root server system. So one proposal would be to have a parallel IPv6 only root server system. So because any changes to the existing root server system are just completely risky and you need to be very, very conservative and cautious, one possibility may be to make a separate system which organizations can use, maintaining the same data, also managed by ICANN, just that it would be using some new topology, some new, like IPv6 only. It might have ECDSA for signatures and some sort of published mechanism for verifying signature roles and things like that. As you probably know, there's issues right now with the IANA root in terms of rolling the KSK and things like that. So, so I think if we hope, so we haven't talked too much about the future, and I guess we'll do that later, but it's possible that v6 only can show us a way to develop a future version of the IANA root server system that can be done in addition to the existing one. So,
okay.
Yeah.
So you mentioned that the rolling of the key signing key of the production internet root server system, and that has been pushed back for a few months now because there's some uncertainty what will happen when the key signing key is rolled, because nobody knows, nobody has done that before, and not in the scale of the internet. Is there any communication between the operators of the original root zone and the Yeti DNS project about doing a test run of these, or is that out of scope?
Well, all right, there's a few issues here. Let me start off with the dirty laundry, which is that when we started the project, the engineers who were involved with it just kind of set it up and did it, as you would set up any zone. And they set up to roll the KSKs every month or every 3 months or something like that. And the problem with the KSK roll and the root is that you don't have a parent to change your DS records at. So for almost every zone, usually except for the root, you don't need a trust anchor because it comes from the root. So what ended up happening is we rolled the key and we did it with a normal roll. The problem is that there's a RFC 5011, which is a way that resolvers can automatically update their trust anchors from the root. However, it has a 30-day hold down timer in there, which is to prevent the root zone from rolling too fast. And I have to admit, I'm not convinced of the wisdom of that, but that's the way the draft is written. And some resolver operators have implemented support for that, and others have not. We noticed that. So what we noticed when we rolled the root without thinking about it or planning it is that the bind 9 servers continue to function properly, probably because the Bind9 developers saw that 30-day recommendation and said, that's ridiculous, and just threw it out. And the Unbound resolvers started failing resolution on the Yeti root. And the reason for that is because probably the Unbound developers read that 30-day requirement and said, okay, it's the spec, we're going to do it. So that was kind of an interesting discovery in itself, but it was also kind of that was early on in the project. Remember how I said it took a little bit longer than we had hoped? That was one of our early discoveries, that maybe we weren't taking this thing as seriously as we need to in terms of organizing and planning stuff. So after that, we stopped rolling our own KSK. So we're kind of in the same situation at the root zone of ICANN, the IANA root. So we have been following with great interest the ICANN plans to roll the ICANN KSK, the real root KSK. The design team for that has come up with some interesting constraints on that problem. We talked about packet sizes and fragmentation earlier. They're very worried about increasing the response size at the root zone. There's been some research which shows that this can cause end users to fail to resolve. On the other hand, we have some real-world evidence that this doesn't cause problems. For example, I believe the org domain would occasionally provide very, very big responses, and nobody has complained about not being able to get to Wikipedia. So it's unclear, but with an abundance of caution, the idea is to try to make the zone as small as possible. So the ICANN design team came up with a carefully designed timeline, kind of like what you were talking about, to keep the packet sizes small in order to roll the keys in a way that you didn't have multiple keys being rolled at once, which would make the packet bigger than necessary. So we've looked at that, and I gave some feedback about this, and there's a process, and now they've kind of committed to their schedule to roll the root. So we had planned for our next experiment after the multi-ZSK to be a series of Yeti KSK rolls. Our intention is to roll the basic way first. So there's a recommendation for a KSK roll in DNSSEC recommended practices, RFCs, and we were going to use that. And then the next step would be to implement a carefully orchestrated roll in a way similar to the way that ICANN has proposed.
Okay, and then compare the two.
Right. So my expectation would be that we're not going to have any problems, but our constraints are quite different from ICANN because we don't have a lot of old legacy software out there. Although by old in this case we mean 5 years, but it's the internet. Things evolve pretty rapidly, and of course we're IPv6 only, so we don't know exactly what the differences would be. But we thought it would be important to indeed see what the differences are and things like that. In the meantime, at the last DNSOARC meeting. DNSOARC is an organization, it's the DNS Operations and Research Center, and it's a group of people who are very interested in DNS. They have a number of facilities, but one of the things they do is twice a year they have technical workshops. And so at the last one, which was a few weeks ago, VeriSign gave a presentation about increasing the size of the ZSK for the root. So right now in the root zone, the KSK, which is managed, as we talked about with these HSMs, is 2048 bits. Mm-hmm. That's RSA algorithm. That's generally considered safe for the next several years, by cryptographers, and these kind of people. Although there has been some discussion in the last few months about moving to algorithms which are resistant to quantum cryptography, but I think that's out of scope for our current concerns. Yep. But the ZSK is signed with 1024 bits, which is no longer a recommended key length. It's considered. It's probably not unsafe. No one's panicking. It's not going to cause major problems, but there is some concern that because of advances in computing power and cryptographers constantly working on new techniques, that 1024 bits is not going to be safe much longer.
Yeah, the security margin is shrinking.
Right. I think by now the estimation is that it might even be possible within a month or so that someone could crack such a key for a state level actor, someone with millions of dollars and highly dedicated trained people. So basically, it's been recognized that we need to increase the size of the ZSK. This is what VeriSign has announced they're going to do. The time frame for this is relatively short. It's actually quite an interesting contrast between the long multi-stakeholder review, technical expert process that we're having for the KSK role, which, to be honest, is much more dangerous and much more important, and the ZSK size increase, which VeriSign kind of just announced, and they're going to do it. So our next experiment that we've actually started is increasing the size of the Yeti ZSK to 2048 bits, and we actually kind of skimped on our experiment protocol. We didn't do a lab test for this because we thought that surely this is simple enough that it will work. And it seems like we've been right. We rolled, I believe we just are finishing up our roll because we have 3 ZSKs to roll. And I think we're just finishing up our 3rd one now. So that experiment is going on. Once that finishes, we will then probably return to looking at the KSK roll as an experiment. Now, the relationship between the people working on the real production systems in the Yeti project is not bad, but it's also not great. If I think a lot of the people involved with the root server system, as well as ICANN, feel quite threatened by Yeti. I don't think they have to feel threatened. I don't really want to criticize anyone's job or take over the world or anything like that. We're really just trying to look at interesting questions and think of interesting and improved ways to deliver service in the future. Nevertheless, people are people. And if I was on the other side, if I was working for one of those organizations, I would feel differently. So so we don't have a close working relationship. Ideally for us, what would happen is someone from one of the current root operators or someone from ICANN or something like that would actually approach us and say, hey, we have an idea for an experiment. Can you please run it for us? We would be happy to do that. We'd say, great, let's do it. I don't think that's likely to happen. I don't think they want to give the project any more legitimacy than it currently has. And I think a lot of people involved may be interested in the results themselves, but not sure if their community would support that. So one of the reasons we're doing everything publicly is so that we can then, it'll give us a way to deliver this information to interested engineers and decision makers in these organizations without having to have a direct dialogue. We can say, by the way, we ran the experiment, you may want to take it into consideration, and then they can look at it, they can replicate the results on their own, they can discard them for information, or these are all possible, but at least the data will be there and they can take these results and hopefully use it to improve the things like the KSK role that are coming up and things like that.
Yeah, I think that is probably the best possible way in the current situation, as political as it is.
Yeah.
How about the software vendors that do DNS software like IC and LNet Labs? You mentioned that Bind9 is behaving differently than Unbound in case of a KSK rollover. Do they participate? Or do the project talk to them, like delivering back any results, problems with software that has been detected?
Well, I used to work at ISC, so I know most of the engineers who are still currently working on this on Bind9. I live in the Netherlands, which is the white-hot heart of DNS in the universe.
The hotspot.
Exactly. We've got NLNet Labs here, and they make Unbound and NSD. We've also got PowerDNS, which makes PowerDNS and PowerDNS Recursor. So I've talked to all of these people. For example, the root zone has a few differences from other zones in the way it returns answers. So in the case of priming queries, bind9 does not return glue records properly. Well, from our point of view, it's not. It needs to be configured differently to return glue information. I actually put together might be a one-line patch, but maybe a three-line patch for bind9, which will change the default behavior and so that it will return glue records properly. Now, to be fair, for that to be an option in bind9 would probably take a few hundred lines of code, because you'd want to have an option configured, you need to document it, you need to test it, you need to have people be able to turn it on or off. And it's kind of a corner case. So I can see why they might not want to make it an option, and changing the default behavior is always risky. So, but we've had a discussion with the bind9 engineers about that. We have also had, we've had people from CZNIC testing their new resolver. CZNIC is the Czech registry, and they've made their own DNS server, the not DNS server. They're currently, I believe, in a beta phase for the not DNS resolver. Earlier on, when they were doing that, they actually used our Yeti system for doing testing of some kind. I don't know. We saw a lot of traffic for them, so I don't know the details there. But we were able to discover a bug in the not resolver. Not really a bug, but a strange way it handled name compression. So it would do name compression on a 0-byte label or something like that, because the root is 0 bytes. Oh, yes. And technically you can compress that, although the compression is longer than the actual uncompressed version. So that wasn't really a bug. It met the spec, although it was
questionable if that is useful.
Questionable. But it did also tickled another bug in the Go language DNS library that Meet Gibson maintains, which is really nice. But it triggered a bug in that, so that was quite interesting. I've also talked to the people from PowerDNS. I mentioned they're another Dutch DNS vendor. They said that the PowerDNS software would not properly serve the root zone, but they took an effort to fix it so it does that. So they actually said that they can actually serve the Yeti server, the Yeti zone, and participate in the project. So I've gotten interest from PowerDNS, and I'm hoping to convince their engineers to run a Yeti root server, because no one else is currently running a Yeti server using PowerDNS, probably because it wouldn't have worked before, and you need to run it out of their latest Git branch. And I talked to some of the people at NLNet Labs. They're interested, but they don't have a lot of time. But we also do already have people running NSD and people running unbound resolvers. Likewise, a CZNIC, I think they're interested. We already have someone running not resolvers, or not servers though, so it's not completely necessary that they be the ones to do it. And we have, of course, people running bind. We run bind ourselves. I think all three of the coordinators run bind for our servers. ISC is in a special place though, because they are not only a DNS vendor of open source software, but they also run the froot name server. Yes. So I've had conversations with many of the root operators to try to convince them to join the project. Some of them are interested, but they're concerned about the optics, about how it looks. Some of them are interested, but they say they need work to convince their communities. Some of them, like ISC, are not interested at all. And I think that, of course, that's every root operator has their own priorities and political position and things like that. So it's not unexpected, but it would have been nice.
If these cannot run for certain reasons or participate with the Yeti root server, maybe someone from our audience can do.
Yeah.
What is the project already full, or is there still a space to participate?
Right. So one of the questions that we want to answer when we started the project was, what are the breaking points of the root server system? So the experiments that we've talked about so far are mostly ones that we expect to work. We expect service to continue delivery, maybe with some slight degradation in quality as packets become bigger and bigger. But basically, we expect things to continue to work. We know that there are going to be some limits. At some point, the system will fail. So, for example, if there were 1,000 root servers, performance would not be optimal,
Yes.
right? But what about 500? Probably not good, but 250? I don't know. At some point, it's going to be bad. And so one of the questions that we hope to answer is how many servers is too many, right? We have other similar questions like how fast can you add and remove root name servers? Right now, the process takes months to do, with typically maybe even a year or two of preparation.
In the original root, not in
in the IANA root. Yes, sorry, in the IANA root. And I don't say, when I say add and remove name servers, I actually mean change the IP address of name servers, because we haven't had any changes for 17 years or whatever. But so these are the kind of questions we want to ask. But when we started the project, the coordinators declared that we wanted to have 25 root server instances. This was not done based on any scientific or mathematical analysis of packet sizes or anything. It was just sort of, if we have 25 root server operators, then we know there's a lot of interest. And that's more than double the amount of root server operators in the ICANN, the IANA root. So one of the questions that political people always ask is, why can't my country have a root name server? And historically, the answer has often been, oh, we'd love to, but there's simply no room left. So one of the things that Yeti project has already shown, which is true for DNS people, we've known this for many years, is that's just a lie. You could have added root name servers for many years now. So getting back to the question of how many can we have, how many root server operators are possible? Today we actually do have 25 instances, 25 entries in the root zone. It's a little bit of a fiction though, because many of those are run by the same operators. There's the first group to do that was a French group of researchers and other people interested in France. They had already run one Yeti root name server, and they wanted to run another one using different software in a different environment. And we thought, okay, that's fine. Then we realized a few months ago that we were not adding new root server operators very quickly. This is because, to be honest, we had been more focused on getting our backend infrastructure sorted out properly and looking at the actual experiments. So we kind of stopped this kind of trying to convince people to join the project activity. But we still wanted to get more servers. So we decided, look, the French researchers have added extra servers, and it seems okay. We'll just add more servers ourselves. So we put out a call to the discussion list of people working on Yeti, said, look, if you want to run more name servers, that's great, let's do it. And we were able to get one other organization to do that. There's a Indian research organization, which now runs, I think, 4, maybe 5, something like that, of the Yeti root servers. And then the BII group, my company, we run, I think, 6 or something like that of the root name servers. So we have a couple problems in trying to decide when to add more name servers. What we'd like to do right now is add additional name servers from additional operators and then remove the ones that we're running, right? We don't want to continue to run them. We'd prefer to have different organizations running the name servers. The main issue there is that we have a lot of name servers in Europe, which is not a problem necessarily. I think it has to do with the fact that there's a lot of DNS in Europe. Because of the CCTLD model, where every country has its own top-level domain, Europe has small countries, and there's a lot of them. So there's a lot of people doing DNS at that level. Plus, it's a rich part of the world. We have a lot of network activity and things like that. A lot of people interested in this stuff. So I think more than half of our name servers our name server organizations are in Europe. So what we'd like to do, what we really want, what would be super exciting for us, is more people in other parts of the world. We don't have any African participants, for example. We don't have anyone in Oceania. We've only got very few people in Asia and only one participant in South America, things like that. So well, anyone who wants to join the project, at this point, we're not turning anyone away. We'll be happy to add more name servers. But if we had our choice, we'd love to have someone in Africa or Australia or New Zealand or something like that, because those are parts of the world that are currently far away from the heart of the internet and don't have as many name servers now. But even if we got, say, 10 more participants and got rid of all of our sort of double name servers, we have no specific reason to not add more. What we would do, I think, is if we got to the point where we had, say, 30 participants, we would probably start looking at the data and try to figure out with the other experimenters, other researchers, what kind of heuristics we want to have for this, right? So at what point do we decide, hey, we're going to turn down an old server and add a new one or things like that? You can imagine a whole bunch of different criteria for that, but we haven't had that problem yet. We may not. Another thing which we didn't mention is that this project is expected to be a limited duration. It's not the project has a built-in end point. It's a 3-year project. We're now 1 year in. We just started the experimental phase. The expectation is that we'll continue this for a while. I mean, we don't have a date that we've all agreed to when we'll shut the project down, but we will probably end it eventually. It's a research project. It's not a production network or anything like that. So
I understand from following the mailing list that also an important part is to have people running DNS resolvers that use the Yeti DNS project. I can imagine there's people from the technical community interested in doing that and maybe reconfiguring their private resolvers to point to the Yeti DNS project. But it might also be interesting not to run the latest software, but in order to find bugs in how does maybe older software, maybe not so often used software react on a KSK rollover in the root zone to run not the latest greatest, but maybe have a good mix in there.
That's an interesting question. Well, another thing that we haven't talked about is proprietary software. All the software that we've been talking about so far has been open source stuff, because frankly, we're network guys. We're quite comfortable with Unix servers and things like that. So we don't have Microsoft in there. There's no Cisco CMS, or I don't know what the CNR. There's no Cisco CNR, which is probably the biggest DNS resolver in the world. Yeah, we don't know. I don't know if that's super important, but that's a missing piece. Older versions of software, that's quite interesting. It might be nice if someone wanted to configure their, Red Hat RHEL version 4 or 5 or whatever the oldest one is, and see what happens with that resolver. It's a bit tricky because, of course, security bugs happen. So you need to make sure it's old but maintained and patched, right? But please don't run bind 8 for this.
No, but old Red Hat Enterprise Linux 5 and 6 are still maintained,
right.
But they have quite old versions of bind in there, 9.6, I guess.
Yeah, that would be quite interesting to see what happens with that. I mean, it's always a problem in the software world, especially in the networking world, about the trade-off between enterprise versus latest and greatest stuff. Administrators usually want stuff to never have to change. It works. Please don't make me upgrade because it's going to break a bunch of stuff and I'm going to have to lose my holidays. Whereas sometimes you say, well, this old one didn't work quite the right way. It's a bug maybe, but it's also just not a very good feature. And so you want to encourage people to upgrade to the way that does everything better, but they don't want to do it. So there's a bunch of tension there, and we haven't really addressed that. So maybe that's something we can talk about within our discussion community. We'd love to have that. We have a really hard time convincing people to run resolvers. It's been a long-standing issue in the project, which is there's a kind of built-in tension there because. So the idea here is that you take your normal DNS resolver, bind or unbound or not DNS resolver, And instead of having it go to the default root servers, the IANA hints, you use the Yeti servers instead. It's actually quite a simple change. We have it documented for 2 types of resolvers, maybe 3 now. So it's easy to do. But because the Yeti network is experimental, it's quite possible that it's going to break at some point. And if we expect any breakage, we will definitely let people know and discuss it on the list in advance. Nevertheless, the reason we're doing these experiments is because we don't know what's going to happen. So we cannot recommend that someone take their corporate internal resolver and point it at the Yeti system, because their boss may get very angry if all of a sudden things break because they got packets that are too big, or because it's using some signature format that's not recognized or something like that. So we have this tension, right? And we've tried to come up with clever ways to work around that. One approach is one that my colleagues have done with the BUPT, the Beijing University of Post and Telecom. And what they've done there is they have some buildings that students go to classes in and meet with their professors, and they have Wi-Fi networks set up. And they've added a Wi-Fi network that uses the Yeti project for its DNS resolution. And I think that's quite an interesting, clever solution, because it's Wi-Fi, and if all of a sudden your Wi-Fi network breaks, you go to another one. People have been trained because of crappy Wi-Fi networks all around the world to do this. And it is a very easy fix for people. So that's quite a nice solution. And we do get a bit of traffic that way. That's a cool solution. And we are also looking at mirroring traffic. Right now, we have the Moscow Internet Exchange is running one of the Yeti root servers. It's also taking some traffic that they're generating locally and mirroring that, I believe, just using a switch to do a passive tap or something like that. And then they send it to a server configured with the Yeti roots. And the advantage there is that they change the source address, so it never goes back to the actual user who's made the query. But we get all of the real queries that the real users are making at this relatively large resolver. The disadvantages of this approach are, one, it's a bit tricky to set up. There's details about how your network is configured and things like that. You need to be comfortable enough with your switches to mirror the traffic and make sure you don't break production and things like that.
And
also,
you don't have any users that complain.
Exactly. So we don't know what happens, right?
Yeah.
We can measure packets and things like that, but if someone gets a bad answer or something validates that shouldn't or things like that, we never know. So it's not the best solution. I'm actually working on just today, writing some software which will take a copy of queries from an IANA root server and then send them to the Yeti root server as well, compare the results, and then make sure that it looks good. So this is still not a perfect solution, because there's going to have to be some fuzziness about the comparison, and we may still have trouble convincing people to run this. What we recognize is that people are busy and they have complicated networks, and the worst thing in the world would be to waste time and break your system at the same time. So we want to make it something that's easier for people to run and is guaranteed not to break things. And we're trying to work on a piece of software that people can run, which will do that and give us more data. They could just a single library they can install, or a single program they can install and run. Even then, people are going to have security concerns and privacy concerns as well. It's a bit funny because no one has any privacy concerns with their DNS traffic going to the root servers, which is all unencrypted, going to any cast IP addresses, which are not all heavily monitored. But nevertheless, sending it to a Yeti system, which is, from the point of view of many people, run by the Chinese, makes people very nervous. Which, just to be clear, it's not run by the Chinese. We're one of 3 coordinators of the project, but that's the perception. So we want to try to encourage that. And that may help us get traffic also from some of these older resolvers too. Don't know.
For our audience, if you want to stay After the interview, I will have a tutorial there how you can configure your unbound or bind resolver to use the Yeti DNS if you want to participate in using Yeti DNS in your resolver setup. And I think the positive side effect, besides all the risk quotes that you have in running that, is that you learn a great deal of how DNS works by operating either a Yeti DNS root name server or participating in running a resolver for the Yeti DNS.
Yeah, I don't want to scare anyone off. We've tried to make it simple. From the point of view of an operator, it's really one or two configuration file changes, and then it does just work just like your normal IANA root. So, if you have IPv6.
Okay. So yeah, I would like to wrap up. Anything that we have missed? Something that we should have talked about but we haven't?
No, I think that covers the main pieces. One thing that maybe we should talk about is the future of the project as well. Yeah. So, as I mentioned, originally the project, we expected it to run 3 years, and I think like all of these things, this is also not done based on a careful project breakdown and analysis of all the time involved. It was just sort of a gut feeling that that should be enough time for us to set it up, get interesting results, and then be done. So we can revisit that if 2.5 years from now we're in the middle of some really exciting, interesting research. Of course, we're going to keep going. And if a year from now, if we look at our to-do list and say, well, that's it, then we'll shut down early, right? So, but the expectation is about 3 years. Now, all of the participants in the project have their own goals and motivations. I'll be honest, some of the participants come from people that want to run root name servers and haven't had that ability in the future. So the idea of Yeti being a production service, there's, as I mentioned, because we're doing experiments right now, there's no expectation this will become a production service. The participants in it have all joined based on this commitment that we made to not modifying the root zone, that it's an experimental network, and so on and so forth. So having said that, what I expect is that at the end of the project, or as the project moves along, we're going to have a clearer idea of some of the possibilities and the things that can work for changing the existing root server system. And what I expect is that we're actually going to make a set of recommendations to ICANN and say, hey, the root server system hasn't changed in, well, by that time it'll be 20 years, but here's some things that we've tried, and here's some model that we think will work. And what's going to happen after that, I don't know. That's outside of the scope of the project. It will be interesting, and the work that we're doing in Yeti will help inform that discussion. But that's something that will be a separate project. It may be that the Yeti project, all the participants get together and say, we want to run a prototype network, a network that we intend as a model that can be adopted by ICANN later. But that will be, I'm hoping that we rebrand the project and we shut down Yeti and make Son of Yeti or whatever. Yeah, and we'll see how it goes.
That's good last words. Thank you very much for your time.
Hey, thank you.
See you next time, maybe.
Yeah. Bye-bye.
Bye-bye.